Look at this image. This is a newly discovered early galaxy that existed about 13 billion years ago. But researchers found that this galaxy was far more massive and mature than expected for a galaxy in the infant universe. This is shocking because, according to the standard model of cosmology, galaxies at that time should have been small, chaotic, and just beginning to form stars. Yet, what James Webb has shown us is something that seems to defy the very foundation of our cosmological theories. Well, this is not the first time that the Webb telescope has found such anomalies in the early universe. Ever since its journey began, it has been rewriting our cosmic textbooks, revealing discoveries that challenge what scientists thought was settled knowledge about the origin and evolution of everything we see. But this time, the discovery goes far beyond surprising galaxies. This telescope has revealed something deeply worrying about the universe itself. Recently, Nobel Prize-winning scientists revealed that the James Webb Space Telescope has confirmed that our understanding of the universe may have been completely wrong. And this is not just about galaxies being bigger or brighter than they should be. This time, Webb's new observations have struck directly at the very pillars of cosmology, at the principles on which the Big Bang theory itself rests. For more than a century, scientists have built cosmology on one crucial foundation: the assumption that the universe is isotropic and homogeneous. In simple words, that means that the large-scale structure of the universe looks the same in every direction, and that matter is evenly spread out when we zoom out far enough. The logic is straightforward. The laws of physics act equally everywhere, so the cosmic structures shaped by these forces should be distributed equally as well. This uniformity assumption is what made the Big Bang theory possible in the first place. If the universe looks the same everywhere, then it must have expanded from a single, hot, dense state, and its current state of expansion should be measurable and predictable. The cosmic microwave background, the faint afterglow of the Big Bang discovered in the 1960s, seemed to support this idea. Its temperature was nearly uniform in every direction, with only tiny fluctuations. This was seen as powerful confirmation that the universe was indeed homogeneous and isotropic. But now, James Webb's sharp eyes and unprecedented reach have raised new alarms. A recent study, published on February 6 in the astrophysical journal Letters, suggests something profoundly disturbing. The expansion rate of our universe is not the same everywhere. Depending on where you look, the universe appears to expand at different rates. This is a huge problem because it undermines one of the most essential assumptions of cosmology. If the universe is expanding at different speeds in different regions, then many of our calculations about its age, its size, its evolution, and its future may all be wrong. David Gross, a Nobel Prize-winning physicist, explained it directly. We shouldn't call this a small tension or a minor problem. This is a full-blown crisis in cosmology. To understand why this is such a crisis, let's rewind history for a moment. In 1929, Edwin Hubble provided the first observational evidence that the universe is expanding. Using the most advanced telescope of his time, he discovered that the more distant a galaxy was, the faster it seemed to be moving away from us. This meant that the universe was not static, as many once believed, but dynamic, expanding in all directions. From this, scientists concluded that if the universe is expanding now, it must have started expanding at some finite point in the past. This was the birth of the Big Bang model. But to truly understand the age of the universe, scientists needed a way to measure the expansion rate accurately. This measurement is known as the Hubble constant. If you know how fast the universe is expanding now, you can rewind the cosmic clock and estimate when the expansion began, effectively calculating the age of the universe. For decades, however, the Hubble constant was filled with uncertainty. Before the Hubble Space Telescope was launched, estimates for the age of the universe ranged wildly, from as little as 9.7 billion years to as much as 19.5 billion years. The lower value created a paradox. It suggested the universe was younger than the oldest known stars, which is impossible. Astronomers tried new methods again and again, but the numbers never seemed to agree. Two gold standard methods eventually emerged for measuring the Hubble constant. The first looked at the cosmic microwave background, the oldest light in the universe, dating back to just 380,000 years after the Big Bang. Between 2009 and 2013, the European Space Agency's Planck satellite mapped this ancient light in incredible detail and calculated a Hubble constant of roughly 67 kilometers per second per megaparsec. This value suggested a universe about 13.8 billion years old. The second method involved using Cepheid variable stars and type Ia supernovae as cosmic yardsticks. Cepheids are stars that pulsate in brightness, and their pulsation period tells astronomers their true luminosity. By comparing how bright they appear to us, astronomers can calculate their distance. With enough data, this method yielded a Hubble constant closer to 74 kilometers per second per megaparsec, significantly higher than Planck's measurement. This difference became known as the Hubble tension. At first, scientists thought it was a simple measurement error. But over the years, with better instruments and more data, the numbers remained stubbornly apart. Adam Rees, a Nobel Prize-winning professor of physics and astronomy at Johns Hopkins University, said it best: "After years of refining the methods, we can rule out measurement error with very high confidence. The tension is real." Now comes the game changer. James Webb's powerful new images have confirmed that both sets of measurements are correct, which means the universe truly does seem to be expanding at different rates in different regions. This is not just a statistical quirk. It points to something fundamentally strange about the cosmos. If the expansion rate is different depending on where we look, then our assumption that the universe is the same everywhere, the cosmological principle, falls apart. Without this principle, our entire standard model of cosmology collapses. We can no longer reliably estimate the universe's age or size because the expansion does not follow one consistent law. So what could explain this? One intriguing idea is that dark energy, the mysterious force accelerating the universe's expansion, is not uniform. Perhaps in some regions, dark energy is stronger, causing faster expansion, while in others it is weaker, slowing things down. If true, this means that the universe is far stranger and less orderly than we imagined. The physical laws we assume are universal might not apply the same way everywhere. Imagine regions of the cosmos where gravity behaves in reverse, where the speed of light is unimaginably slow, or where bizarre possibilities like unicorn-like physics might be real. This sounds absurd, yet scientists are forced to confront these questions. The Webb telescope has triggered a massive debate among astronomers and cosmologists. If the universe is non-uniform and anisotropic, then much of what we thought we understood, the Big Bang, cosmic inflation, dark matter, dark energy, may need to be rethought from the ground up. And this brings us to the deeper crisis. The Big Bang model relies heavily on the assumption of uniformity. It explains the cosmic microwave background, the distribution of galaxies, and the large-scale structure of the universe. But if the expansion is different in different directions, then the universe may not have begun in the way we thought. Perhaps the Big Bang is incomplete, or perhaps something more exotic occurred, something that defies our imagination. Even more unsettling is the possibility that the true age of the universe could be wildly different from our current estimates. If some regions expand faster and others slower, then the clock of the cosmos does not tick at the same rate everywhere. This could mean that the universe is older than 13.8 billion years or younger, or perhaps that the very concept of a single universal age is meaningless. For cosmologists, this is nothing short of a nightmare. Every model we use to understand the cosmos depends on having stable, universal laws. If those laws vary from one region to another, then predicting the universe's fate becomes nearly impossible. Will the cosmos expand forever? Will it collapse back into a singularity? Or will it fracture into strange, disconnected regions with completely different physics? As unsettling as these possibilities are, they also open the door to new physics. Perhaps dark energy is more complex than a simple constant force. Perhaps it interacts with matter and space-time in ways we have not yet imagined. Or perhaps there are hidden dimensions or new fields at play, clues that could lead us to a grander theory beyond the Big Bang. James Webb was built to answer questions about the first stars and galaxies, but in doing so, it has raised far deeper ones about the very nature of reality. It has shown us that the universe may not be as uniform, predictable, or comprehensible as we once believed. Instead, it may be a patchwork of strange behaviors, an intricate mosaic where the rules of physics twist and shift depending on where you stand. This is not just an astronomical puzzle, it is a philosophical one. If the universe does not follow one set of universal laws, then what does that mean for our place within it? Are we in a privileged region, where the laws are stable enough to allow stars, planets, and life to exist, while other regions are chaotic and lifeless? Could it be that our understanding of the cosmos has been limited by the tiny patch of universe we occupy? For now, what is clear is that we stand on the edge of a new revolution in cosmology. Just as Einstein once overturned Newton's universe, and just as Hubble revealed an expanding cosmos, Webb may be showing us that the universe is far stranger than we dared to imagine. And in that strangeness lies the next great discovery, the next leap in our understanding of who we are, where we came from, and where we are going.